we may start to mine both the asteroids and the Moon. But before that occurs, our most likely option for obtaining extraterrestrial resources is space-based solar power. Space-based solar power, also known as just space solar power, would generate off-world energy by placing solar power satellites in orbit. These would receive sunlight before it hit the Earth and would wirelessly transmit their collected energy to a receiving station on the ground. For safe operation, wireless power transmission frequencies would need to be chosen that would not damage animals, plants or machines caught in the beam. Solar power satellites would be immune to cloud cover for changing seasons and atmospheric haze. In a geostationary orbit some 22,000 miles above the Earth, they would also be largely unaffected by nighttime shadow. Solar power satellites therefore have the potential to be many times more efficient than ground-based solar power installations. Designs for a space-based solar power system were first developed by an American engineer called Peter Glaser, who, in 1973, obtained a patent for his method and apparatus for converting solar radiation to electrical power. This envisaged solar power satellites with microwave antennas that would transmit power to large Earth-based receivers called rectennas. Since Glaser's patent was granted, significant development work has taken place in the United States, Canada, Europe, Japan, China and India. For example, in the 1970s, NASA and the US Department of Energy spent about $20 million on feasibility studies. Between 1995 and 1997, NASA again looked at space-based solar power under an initiative called Fresh Looks. In 2007, the US National Space Security Office also presented a detailed analysis, while in 2009, Pacific Gas and Electric and the Japan Aerospace Exploration Agency both put forward ambitious plans. By 2010, in Europe, EADS Astrium also began to seek partners for a demonstration mission. In 2011, the International Academy of Astronautics, or the IAA, then produced its highly detailed first international assessment of space solar power. According to the IAA report, there are no fundamental technical barriers that would prevent the realization of large-scale solar power satellite platforms during the coming decades. Having considered many possible approaches, the IAA also highlighted three as the most viable. The IAA's Type 1 architecture is based on a now classic solar power satellite reference system developed in 1979 by NASA and the US Department of Energy. Here, one or more very large arrays of photovoltaic solar panels are coupled to a microwave power transmission system. The architecture requires a large stabilized platform that rotates on three axes to keep its solar panels pointed at the Sun and its power transmission dish targeted at a receiving station on the Earth. The IAA's Type 2 system transmits solar energy down to the ground using multiple lasers that target a photovoltaic rectenna. While solar-pumped lasers could be used to directly channel focused sunlight to the Earth, electric lasers are likely to prove more effective. Here, sunlight would be turned into electricity using large photovoltaic arrays as in a Type 1 system. But the power would then be transmitted down to the ground by many laser beams operating in the near-visible part of the spectrum. A Type 2 architecture could comprise an integrated platform with multiple laser installations, or a constellation of single laser satellites. Finally, the IAA's Type 3 system is based on a symmetrical optical concentrator or sandwich design that does not require very large photovoltaic panels. Rather, vast arrays of mirrors several kilometers across collect and redirect sunlight onto much smaller photovoltaic solar cells. The electricity so created is then transmitted to the Earth via a single microwave link. Such an approach requires a less complex power management and distribution arrangement than in a Type 1 or Type 2 system, as captured solar energy will be largely moved around via light redirection rather than through a physical electrical infrastructure. Type 3 systems may therefore prove the most viable to construct. Interest in space-based solar power has been growing for over 40 years. Many tentative ventures have even been announced, although no major industrial player or government has yet committed significant resources. This said, several smaller firms, including Space Energy and PowerSat, continue to pioneer. All of the technologies required to build solar power satellites also already exist, with advancements in the necessary solar technologies continuing to be made. The transmission of energy over long distances using either microwaves or lasers is also long since proven. A few decades from now, Peter Glazer's vision of obtaining power from space may therefore become a reality.